While studying the chapter elasticity, we will come across two terms, specific terms, stress and strain. Here, we will study stress in detail. You know, deformations could be of four types. One is length, the other in volume, one in shape and the other in the torsion nature. Four types of deformations are possible. We have focused here on three only, that is length, volume and shape. When length is subjected to change, it is longitudinal. When volume undergoes the change, it is volumetric, and the effort is there to change the shape, then it would be known as tangential. When the forces are applied, deforming forces, intermolecular forces will have a tendency to oppose the deformation. This restoring force or the intermolecular force acting per unit area, that would be known as stress. You see, longitudinal stress means some wire is subjected to hangover, but necessary is not the hanging. It could be even maintained horizontal and you are pulling this way, then also it is longitudinal stress. Whenever you are stretching or compressing the cylinder, longitudinal stress is going to take place. When the length increases or the stretching is there, it is called tensile, and when you are pressing it inward or compressing, then it would be known as compressive strain. Tensile stress and compressive stress likewise will take the name strain. Volumetric or bulk stress. You consider the example of balloon. Balloon is just pushed this way, that means you are applying the force normally. You take a cylinder full of gas and the above side is their piston which is movable. Now, if you just press the piston downward, you are applying the force normally. This normal force is going to change the volume. So, we could say in short, whenever the force is applied, deforming force is applied normally, it is to result in volumetric change, and the stress there would be known as volumetric stress. You see, the stress is force upon area and pressure too is force upon area. So, you could say the longitudinal stress is force upon area. If force is mg, you will replace force by mg. Here, if the normal force applied here is F and area is A, again you will get the same value as that of the pressure. Now, just consider one example of tractor tire, big tire, not ordinary car tires. I am talking about big tractor tire or the tires of crane. You see, would be of this height. You put your hand on the tire and try to push the tire downward. You are applying the vertical force, but now you suddenly change and try to pull this way. This is going to be the tangential force. This is the nature of tangential force. Now, if the tire is fixed at the bottom, it is going to change in shape. Similarly, if you take a rectangular body and put your hand and apply the tangential force this way, it is going to change in the shape. There also you will define tangential stress as force upon area. Remember, tangential term might be replaced by shearing also.